Solar flares. The sun's powerful bursts. Hello and welcome. Today, we're diving into a fascinating topic: solar flares. These are powerful bursts of energy from the sun that can affect space and life on Earth. Let's explore what they are, how they happen, and why they matter. What are solar flares? Solar flares are sudden flashes of brightness on the sun's surface. They happen when magnetic energy stored in the sun's atmosphere is released quickly. This release sends out a huge amount of light and energy, including X-rays and ultraviolet rays. Imagine the sun's surface as a boiling pot, with magnetic fields twisting and snapping like rubber bands. When these fields break and reconnect, energy bursts out. That's a solar flare. The sun's outer layer, called the corona, is full of magnetic fields. These fields get tangled and stressed over time. When they snap or rearrange, they unleash energy in the form of solar flares. The process starts with sunspots. These are dark, cooler areas on the sun's surface with strong magnetic activity. Sunspots are often the birthplaces of solar flares. The magnetic lines around sunspots twist too much, they release energy as a flare. Types and strengths of solar flares. Scientists classify solar flares by their X-ray brightness in three main categories. C-class flares, small and common. These flares cause little effect on Earth. M-class flares, medium-sized and can cause minor radio blackouts on Earth. X-class flares, the biggest and most powerful flares. They can disrupt communications, satellites, and power grids. The scale is logarithmic, meaning an X-class flare is 10 times stronger than an M-class flare. Effects on Earth and space. Solar flares send energy and particles into space, sometimes hitting Earth's magnetic field. This can cause auroras. The northern and southern lights become more active and colorful. Radio disruptions. Shortwave radio signals can fade or go out. Satellite damage. Strong flares can harm satellites or affect GPS signals. Power grid issues. In extreme cases, solar flares can cause power outages. Because of these risks, scientists watch the sun closely to predict flares and protect technology on Earth. How are solar flares detected? Space agencies use satellites like NASA's Solar Dynamics Observatory to monitor the sun in real time. These satellites measure X-rays, ultraviolet light, and magnetic fields to detect when a flare starts. Ground stations also track radio signals to spot disruptions caused by solar flares. The sun's 11-year cycle in solar flares. The sun goes through a roughly 11-year cycle of activity, called the solar cycle. At the peak, or solar maximum, sunspots and solar flares happen more often. During solar minimum, the sun is quieter, with fewer flares. Understanding this cycle helps predict when Earth might face more space weather effects. Why do solar flares matter? Solar flares remind us that the sun is an active star, not just a constant source of light. They affect our daily lives by impacting communications, navigation, and even power supplies. Studying solar flares also helps us learn about the sun's behavior, space weather, and how to protect our technology as we explore space. Final thoughts: solar flares are powerful and beautiful events from our closest star. They show the dynamic nature of the sun and its influence on Earth. Thanks to science, we can watch and prepare for these bursts of energy, keeping our modern world safe. If you enjoyed this deep dive into solar flares, feel free to ask for more on space or science topics anytime.